I just want to do this is a graph interpretation again. It's really where they've given us two parabolas that intersect, and we're going to go through and we're going to work out the lines. It's a short session, so why don't you take it down and work it with me and go through the concept. You know, there's errors that are going to occur in the arithmetic side, but if the concept is well grounded, we can then get rid of those errors by doing things like brackets and making sure that when we are not 100% sure, use this to help you, okay? As we say, don't always believe it, garbage in, garbage out, remember, but it's always a great help. Let's just have a look at this example here. Example, we are given f of x equals minus x squared plus 2x plus 8. And given g of x equal to x squared minus 4x minus 12. So there's our two quadratics, and shown below not to scale. And let's have a look. Right, they could say draw it. They could make it a long question, right? Draw the two graphs on the same sets of axes, right? And then solve the questions after it. If you had to do that, how would you do it? Well, you'd put equal to 0, and you'd go minus 1, minus 2, and 0. There's the 1 point, and there's 6 on the other side. Sorry, 4, 2, 4, and 6. So that's 4 and 0, and 6 and 0. I'm just putting in my my parabolas. This one is down here, so it goes through and goes through 6. I drew it like so, like that. And my other one also went through there, and 4. Okay, so it goes up here, and we're going down there like that. Okay, and she goes up and down there like that. Okay, I've just drawn it roughly. Okay, no big deal. Now, find the vertical height where P and Q, all right, they draw a line here, P and Q. And remember, this drawing is NTS, not to scale, right? I've just basically drawn it. Right, they want to know, find the vertical length where PQ is a maximum. In other words, remember we said, let's just go back and understand, this line here can go anywhere from there to there, can't it? Okay, it can go anywhere from there to those, and at this point it'll be 0, and at that point it'll be 0. Okay, so they want to know where it is a maximum. Okay, now the line can move from minus 2 to the point where f of x is equal to g of x. All right, so now we need to find an expression for the length. They could ask us, find an expression for the length of PQ. Expression for the length PQ. Okay, great. What do? We say length of PQ is going to be top minus bottom. And the top function is going to be, this one is f of x, this one is g of x over here. So it's going to be f of x minus g of x, right? Which is going to be brackets minus x squared plus 2x plus 8 minus x squared minus 4x minus 12. And we remove the brackets, we get minus x squared plus 2x plus 8 minus x squared plus 4x plus 12. Okay, this is where the errors occur generally, guys, in there, right? What's the next step? The next step is to say, okay, and here we now have a function. Oops, sorry. We simplify this and we say, we then have a function of minus 2x squared plus 6x plus 20. Okay, what is this? It's a parabola. And they've said, where is it? They want to know, where is it a maximum value? Okay. Where is a parabola a maximum value? At its turning point. Right? Obviously, it's a maximum value at its turning point. And how do we find a turning point? How do we find turning point? Well, as far as I'm concerned, the quickest way is just to say the x value of the turning point is minus b over 2a. Obviously, your calculators give you the turning points as well these days and the maximum values. You could get it from there. Okay, and please note the parabola, just have a look here, is negative. Therefore, a maximum value. It turns that way, doesn't it? It's got a maximum value over there. And at that point is where we get it. And at that point we go and we say minus b is minus 6 over 2 times minus 2, which is going to be 6 over 4, which is going to be 3 over 2. So at x equals 3 over 2. All right? Therefore, the length equals, and we're going to substitute minus 2, 1.5 squared, plus 6 times 1.5, plus 20. All right? Therefore, we're going to say the length is equal to 24,5 units. All right? That is going to be the length of that. Now, let's just check. Hold on. Let's just check and see that, shall we? Well, we said that the length is going to be a maximum at x equals, and we said 1.5, 3 over 2. So at x equals 3 over 2, that's where it's going to be equal to that 24.5 units. Let's just check, shall we? All right. Let's just check ourselves. Well, quite straightforward. How do we do it? Well, let us find, first of all, right, we know we've got those two heights there, all right, and y1 and y2, right? And therefore, y1 is going to be equal to minus, I'm putting in the 1.5 squared plus 2 times 1.5 plus 8, and that comes out to be 8.75 units. Y2, I'm putting in 1.5 squared, minus 4 times 1.5 minus 12. Okay, you can see which one I'm putting this into. Let me just write them next to them, just for completeness sake. It's f of x is going to be equal to okay, x squared minus 4x. This is x squared minus 4x minus 12. Okay, this was g of x. And this one is f of x here. I substituted into that. Minus x squared plus 2x plus 8. Why? Because I'm trying to find, given x, find y. Find the height at that point, right? And I get over here, for my answer, I'm going to get minus 15,75. So therefore, the coordinates here are going to be 1.5 and minus 15,75. And the coordinate there is going to be 1.5 and 8.75. Well, in that case, tell me how long is this line? Okay, its delta y is going to be equal to, I can just do it over here, 8.75 minus 15.75, which is going to be equal to 24.5 units long. All right? So you've taken, once again, the top function, subtract, doesn't matter what it is, okay? Hyperbola and a straight line, we'll do some when I get to test prep. a few more but in them, it's just the recipe that you've got to work out. Where you have lines involving, let's just quickly, because this is a short video, but just if I had to say, just for example, where we've got a something like that, and we've got a line going through there like that. Remember, this is going to be, let us say, y is equal to 3 over x, and your other line y is going to be equal to, let's say, x plus 3. This is x plus 3. This is y is equal to 3 over x. When you're working with hyperbolas, you're going to get 3 over x equal to x plus 3. Remember the trick to solve this? Multiply through by x. Okay? So in those ones where you've got hyperbolas, all right, you have an x and you multiply through by x, you're going to get an x squared term. If it's a parabola and a hyperbola cutting, you're going to get an x to the cubic term, all right, which you're probably going to have an x that factorizes out to have 3 terms. Because remember, when you solve it, if you've got x plus 2, x minus 3 equal to 0, you then say x equals 0, x plus 2 equals 0, x minus 3 equals 0. Okay, you put them all. That gives us the solution of a cubic. Okay, there may or may not be one. I doubt it, but if there is, you can solve it like that. Also, remember, your calculators can solve them as well. Some of them can. Okay, as I say, that's a short one. I just wanted to finish that section. The next we're going to start looking at trig functions and trigonometry, which is once again quite a big section like functions. So this year we're going to spend a lot of emphasis on trig. Thanks for watching. I hope that you come right with these. Please look at it again if you have to. Just go through the steps with me and see where it is. Essentially not a complicated section of work. It looks far more complicated than it is. And just before I go, one last thing. What do we do when we've solved a coordinate of a point or whatever? Put it on the graph. Why? So the more coordinates you put on the graph, the fuller it becomes of the information that you're going to use to work out the next one. Okay? Cheers. Have a great one. Bye.